Alrighty. So, today we have kind of one last little bit to talk about. A very minor kind of vocab thing, I guess. Um, but let's start off with finding out where my phone is so I can stop it from buzzing. Oh, there it is. Okay, go away. Um, let's start off with talking about kind of our plan for the rest of the semester in terms of scheduling. So today is pretty much our last lecture for what that really is. There's not really much left to talk about, but that's it. So today is going to be a kind of our last new material thing. So what I have in mind. Go away, scam likely. I do not want you. So tomorrow and Wednesday, what I would suggest is you spend the time working on your lab projects. And review your old exams. The ones from this semester, or you can use the practice exams too, it doesn't really matter. That's what I would suggest doing this week. Because the week after, on the 30th, the 1st, and the 2nd, we're going to have time to review your lab projects with me. And so the more complete they are by the time we do this review process, not only the more feedback I can give you, but you'll have it pretty much out of the way then. If you have a pretty much done project that you give to me next week, I can say, hey, change this, add this here, take away this sentence here, and that's it. And then you have just one thing to do really before you submit it, and then you can get an awesome grade on it. However, if it's only like halfway done, then I can only give you feedback on the half you've done, and then say, hey, this whole part is missing here. You'd probably want to include that, but I would not be able to give you as good of feedback that way. So I would suggest, therefore, that you spend this week kind of doing as much as you can towards that, so that next week, while we have our review time, you can use that more efficiently. If you're curious, I did send an email as well as put it in Discord, but there is a website here that you can click on to kind of take you to this kind of sign-up dealy, where you can kind of just choose a 15-minute time slot that you'd like to work with me on. It does not have to be your entire lab group. It can just be one person who then conveys all the information to the rest of you. Hopefully everyone will have at least one person in their lab group who will be able to make it. It's not mandatory, so if you do not want to have me review your thing, totally don't worry about it. Well, maybe worry about it, because then you're kind of going blind into it. So but not mandatory. It will not affect your grade directly if you do not want to review it with me. So that's going to kind of be that idea. What I'll do on the 3rd is we'll have another stream where we can do kind of questions and answers like always. So during your time of reviewing your old exams and stuff, if you come across a topic, thermochemistry, that you would like to find out some more practice about, I don't know, whatever, something that comes up in there that while you're reviewing, kind of the old material, like if something comes up that you'd like to ask, we'll do that on the 3rd as well as the 7th. So we'll have two Q&A days that we'll have streaming. Your project is due on the 6th. So again, if you are, if you make an appointment on the 30th and you already have it done, and I give you your feedback and it's like, add these 4 sentences, you can just add those 4 sentences, throw it in there, and you don't have to worry about it anymore. So, but of course, our nature is to wait until the 6th to do it anyway, so that's, normal. But since this is, you've had, 3-4 weeks to work on this, I would be very hesitant to accept late ones. So make sure you make that due date. So submit it the day before. You've got plenty of time. So get that out of the way. On the 7th, we'll have another stream Q&A for the last minute stuff. And then we'll have your final exam will be, I'll write final exam. You'll be able to take it either of those days. Or I guess you could take it at like 11 o'clock on the 8th and continue on to the morning of the 9th. Totally okay. I'm expecting it to be about 2.5 hours, 50 questions. So it'll be, of course, stuff all over the place, but it will be probably half of the stuff will be the most recent chapters, and then the other half will just be from all over the place. So it would be a good idea to therefore spend maybe half your time reviewing, the gases, the intermolecular forces, and the solids and liquids, and then the other half of your time, reviewing old stuff. So that's what I would suggest for that. So yeah, we kind of just have 2 streams left after this, and those will be Q&A questions. So you'll just put up questions. As always, they could be exam questions, homework questions, just general questions, whatever. As usual, put those up there. We'll have a look at them. Even if you can't make it to the stream directly, hopefully by now you realize I'll answer it anyway, and I will try to do it in as much detail as possible so that if other questions come up, that I can hopefully kind of preempt those. So this will be at 10:15 as our usual class time. So that'll be that. Alrighty. Any questions on this kind of schedule of what's coming? As always, of course, you can throw questions at me in Discord. Of course, by now that I'm happy to answer them at 3 in the morning, just because that's the sort of person I am, I guess. So please don't send me questions at 3 in the morning. Well, I mean, you can. I just won't get to them. But yeah. So yeah. Anything else I need to talk about with this? No, I think that's kind of all I want to talk about the schedule. Any questions on that? Anything else you'd like to maybe see? If one of the review days doesn't get taken up, by the way, we can do more review then. Just because there's 8 slots per day, but there's 11 groups for you guys, and I think 5 or 6 for the other class. So that would be like 17 or 18 groups if everybody wants to do them. And there's 24 time slots, so if we do have a block of time, we can use that for reviewing questions and answers as well. But yeah. Okay, well, if there are no questions, I will give us our last vocabulary word for the day. Or actually for the semester. Oh wow, we're almost done. So, last thing we're going to talk about is alloys. And these are going to be mixtures. Actually, they're the more aptly called solutions, where the solvent is a metal. So example of alloys would be something like steel. You've got stainless steel as another one. Bronze. What else? You've got like sterling silver. You've got kind of things where you have a metal as your solvent and you've thrown in some extra stuff. So, for example, steel is made mostly of iron, but you've thrown in some carbon. Stainless steel, you've got some, you get kind of have that iron as your base one, but you're also now throwing in some chromium and some nickel as well as the carbon to give it some of that corrosion resistance. Bronze is made of tin and copper, and then sterling silver is silver and I don't know, I think copper is the other one. Brass is another one. That's zinc and copper. You have all sorts of fun little alloys. You don't need to memorize these by any means. Um, but suffice it to say, we can have two types of alloys. The first type you have is what's called interstitial. And if you've taken your biology, interstitial space is kind of the space between cells. And that's exactly what it's going to be in terms of a solid. So here's our, we've got our nice atoms arranged here. And as you can see in this particular structure, I've got some gaps. And so maybe some of these extra atoms that we're putting in, like maybe they're copper atoms and this is iron or something, we're kind of filling in the holes. So your extra, your solutes will kind of fill in some of these gaps in between your metal. Of course, typically your alloys are not made of like a 50-50 mixture. Usually they're mostly one element, and then they're just bits of the other one. So like steel is like 4% carbon or something. I'm making this up, but somewhere around there. And so you can imagine if steel were interstitial, you'd have carbon just here and there along your thing. They wouldn't fill in every single gap. They would just be in random gaps. So that would be an interstitial alloy there. Other ones you can have are called substitutional. So interstitial ones are usually when your solutes are smaller than the rest of your atoms, but substitutional ones can be when you're of similar size. So again, you've got your like nice metal here, and you will just basically replace one of your regular like areas where your normal atom would go. You would just replace it with the alternate atom. So one of your solutes. So maybe bronze or something where that's copper and tin. Maybe, I forget what the mixture is, but maybe here we'll put another one. Maybe the black ones are copper and the green ones are tin. Who knows? Where normally you just have your coppers atoms together, and now you've just taken some of those coppers out and replaced them with tin atoms instead. And so those would be substitutional. And there we have it. That's the rest of the material that we had for this semester. So we've talked about two different types of alloys. We've given you some vocab. So substitutional alloys will kind of just replace metal, I mean the solvent. And so you're not going to be asked how to predict if something is going to be interstitial or substitutional. You might just be asked the type of alloy in which solute particles are filling in gaps between atoms is called blank, and then it's interstitial. It's an interstitial alloy. It would be that sort of thing where you're kind of just giving the definition or something like that. These it's kind of hard to apply to. So if I were in the mood to give you homework, I could make you do some sort of like packing efficiency calculation where we're throwing in an interstitial atom, but that just seems pointless. So we're not going to worry about that. By the way, we don't have any more homework, so I'll put up for you guys some problems on solids, but I will also put up the key. So you're not going to have to do any homework for this chapter. That's going to be graded. You'll just be able to do it if you want to, and then just check the answer keys to make sure you're doing it right. So I'm not going to be collecting it or grading it. As you already know, I have way too much grading to do anyway, so we'll make it easier on all of us in that regard. And I'll also throw up a heating curve problem, since I did not give you one of those for homework. and I'll give you the key for that as well. So yeah, we're done. Isn't that awesome? So, any questions on these two vocabulary terms, or on the schedule, or anything like that? All right. Well, if there aren't any, um, you know, have a nice and happy Thanksgiving. Spend some time with your loved ones. Be safe though, of course. If it's grandma you haven't seen in a while, do your best to keep grandma safe, right? So, um, be smart about Thanksgiving. Have some fun. You've earned it. You know, spend the weekend. Having fun with everybody, and then you can come back to chemistry the week after. So, um, yeah, so cool. All right. Stay safe, be happy, enjoy your Thanksgiving, eat a lot. Yeah, kind of, Kevin. That's kind of the biggest thing is the size will be kind of your most important factor there. There may be some kind of other properties, electronic properties that may figure in as well, but by and large, it's going to be size. Obviously, if you can't fit, if you pick a giant lead atom or something, it's not going to fit in the interstitial space. It's going to have to substitute something. Um, so, yeah. Or you'll have some sort of horrible defect if it tries to be interstitial. So, um, those probably would not be very useful alloys if that were the case. So, but yeah, okay. As always, feel free to throw your questions in Discord. Um, enjoy your kind of days off here. Next week, I will see you for lab reviews if you like, and then I will definitely see you on Thursday for questions and answers if you have any. So, yeah, I guess that's it. Congratulations, you have survived COVID Chem 111. So, we are, 2 days ahead of schedule, which is awesome. So, we have basically break time. Where you can lament that I should have gone slower in the thermochemistry or something, but I think we made pretty good pace. So, alrighty, we're done. See you guys next week. Stay safe. Happy Thanksgiving. Have a nice weekend. Enjoy working on your stuff. Here's the dogs. There you go. They're cuddling on the thing. There's some Tupperware around them. Yeah. Have a safe weekend, everybody. Take care.